Evolution can be defined as the indefinite phenomenon of things changing. Being is a versatile title. While organisms are a common subject, buildings, cultures, personalities, ecosystems, planets, galaxies, the universe may all be said to evolve. But though sharing in common the trait of change, what phenomenon a culture undergoes when it's said to evolve is as vastly different from what an ecosystem undergoes as either are to what a building undergoes.
For brevity's sake, we'll focus on the evolution felt by genes, organisms, and their populations. Life is not invincible. Nucleic acids, genes, the biological soul that when exposed to proper conditions creates full living things, can die under mild circumstances. And the hands of time are far from mild. To last until now, life has employed the tactic of reproduction. Genes create copies so that if a single instance breaks down, its peers may carry on. In fact, genes are so good at creating these copies that pandas, with genomes of more than 1,000 genes, which interweave, subdue, and enhance each other, can birth more pandas. Not polar bears, not unliving piles of flesh, more pandas. Of course, even genes will slip up. Nothing is perfect. This brown-haired cub is, however, lucky. Of the many potential lethal changes in their genome, they only received an aesthetic difference. Different groups of organisms have different rates of genetic slip-ups, and this rate can be increased by external factors. Within a single organism, genetic slip-ups can birth all manner of disease, but most of these copying errors, whether neutral, harmful, or perhaps beneficial, live and die within their host of origin. However, on occasion, an inheritable mutation occurs. Mutations seldom revert for much the same reason organisms produce offspring consistent with themselves. Genes are extremely good at replicating, but lack a future goal. A mutant will not desire to make ancestral genes, they'll do their best to self-replicate. Life's variety sprang from one self-replicating ancestral form, which made occasional deviations. These self-replicating deviants had their own deviations, as did those deviants, and those, and those. For eons, this process has run, and hopefully it will for eons more. Life is varied. Even species with a common ancestor, not many generations removed, can be wildly different. However, popular trends like fish with scales or trees with bark exist. There's a reason. Part of why genes replicate so well is their ability to create protective environments known as organisms. Furthermore, these environments, organisms, aid genes in replication beyond providing safe haven. Should organisms be damaged, however, their abilities will be lowered. Keep in mind, different threats harm in different ways. Just because scales and bark protect against fangs and claws, doesn't mean they stop toxic metals. In fact, traits good against one threat may prove detrimental when encountering another. It's important to remember that evolution cares more about a trait's ability to help a gene replicate than about said trait's usefulness to a gene's organism. In fact, traits can be outright detrimental to an organism if they help the gene of said organism replicate. Of course, usefulness to the organism is still important, but only because organisms are so important themselves to genetic replication. From heat, cold, dryness, wetness, resource scarcity, direct predation, and more, genes face many types of hurdles. Some are local issues, some are widespread. No trait can protect against every possible danger. Ultimately, genes that replicated despite local threats continued, while the rest vanished.